Majority of people, even those who are not familiar with math, have heard about the pi number and know that it equals to 3.14. But not everyone can explain where this constant came from, what it means, and why it's so important. Some people know or guess that pi is associated with a circle. If you see a circumference, a circle, or part of a circle, if you see something around, sooner or later the pi number will appear there. If you remember formulas for areas, volumes of any round or partially round bodies, such as sphere, cylinder, cone, they all contain the pi constant mandatory. Oppositely, there are no round parts in these figures, so our fascinating constant has nothing to do here. So let's figure out what kind of animal is pi number. Let's take something round, for example a watermelon. We need to measure the circumference, the perimeter of the watermelon. To do this, it's more convenient to cut it into two halves, take a rope or thread, pull it around a watermelon, and then measure the thread with a ruler. Let's say we got 128.5 centimeters. Now we need to measure the watermelon diameter. We use a ruler again and we get that its diameter is 41 centimeters. Now we divide the first number by the second one and we get about 3.13. Now let's take another round object, much smaller, for example a pea. Accurate measurement of a pea is problematic, of course, but we asked to help a friend who is a gnome. He has performed everything and reported that the perimeter of the pea is 14.2 millimeters and its diameter is 4.5 millimeters. Well, let's divide the first number by the second one. We get about 3.15. Now, for the sake of curiosity, let's take a much bigger object. What can be big and round? I would suggest to take our planet. Why not? We will not cut it, because we have to live on it. And we don't need to measure it. This job is already done by other people. Just open Wikipedia and find out the circumference of the Earth is approximately 40,000 kilometers, and its radius is 6,378 kilometers. But we need a diameter, so we doubled the radius. I can't wait to divide the circumference by its diameter. The result is, voila, 3.14. In all these cases we obtained numbers very close to pi. In the latter case, our results aligns pi up to almost 4 digits. You see how important it is to have good raw data. If our watermelon and pea were a more regular round shape, and we measured them not with a ruler and a thread, but in a more accurate way, then we would also get 3.14, that is pi constant value. So we figure out that pi number is the ratio of perimeter of a circle to its diameter. It doesn't matter what size of the circle is, the size of the galaxy or a mosquito's ear. This ratio is always the same for any circles and equals 3.14. We could also say that perimeter of any circle, no matter whether it's large or small, the perimeter is always 3.14 times greater than diameter of this circle. In fact, we wrote down a formula to find the circumference of a circle. If the diameter of the circle is known, then its perimeter can be easily calculated by multiplying this diameter by pi. Very convenient. As I already mentioned, in all figures and bodies where a circle is present, or something round, or at least a hint at being round, then the pi number will certainly appear there. If you don't know what this constant equals to, you will be able to calculate the lengths, areas, volumes of many figures like spheres, cones, cylinders, arcs, sectors, or other round bodies. If you like, you could reproduce our experiment with pi measurement. You can use any round objects of different sizes. The rounder they are, that is more regular round shape they have, and the more accurately you measure them, the more precise pi value you will get. The first geometrician in antiquity did exactly the same procedure. It took a long time before pundits came up with ideas of more accurate and complicated methods and algorithms. 3.14 is a shortened, rounded value of pi. In fact, pi has an infinite number of digits. Modern computers can calculate this number with precision of trillions of digits, but this is still just the tip of the iceberg. We are unable to see the entire iceberg and write down pi in its final form. Any of the records will be incomplete, approximate. Recording this number cannot be completed. It can be interrupted only. See the endless depths, the abyss hidden behind this number. Pi is an irrational number. That means that it cannot be represented as a ratio of two whole numbers, for example this or this. In other words, it's impossible to find two integers, such so divided one by another will give us the pi number. It would be too cool. I'm writing down two simple numbers, one in the numerator and the second one in the denominator. And here you are, pi. No need to mess around with trillions of digits. But the nature, alas, did not present this gift to us. Don't feel relaxed. Pi has become a hero of numerous jokes, comics and anecdotes. Films, books were dedicated to this constant. Even monuments were erected. Perhaps the best books about this have not yet been written and films have not been created. Who knows, maybe one of you will do this.